லைவ் போயிட்டு இருக்கு. 30 மினிட்ஸ் 30 செகண்ட்ஸ் ஆயிட்டு இருக்கு. சார் பிரின்சிபல் சார் வராதுங்க சார்.
ஆமாண்ணே, பிரின்சிபல் சார் வராதுங்க.
சார் ஹெச்ஓடி சார். சார் ஹெச்ஓடி சார். சார் ஹெச்ஓடி சார்.
அண்ணே, பிரின்சிபல் சார் வரேன்னாங்களா, அவங்க வெயிட் பண்ண சொன்னாங்க. மார்னிங் அண்ணே.
சார் ஹெச்ஓடி சார்.
Hello.
Good morning, sir. Good morning,
sir. Good morning, sir.
Very good morning. Very good
morning, sir.
Welcome, sir.
Thank you. Thank you, sir.
Okay. Yes. Shall we start, sir?
Yes, sir.
Secretary sir, வந்துட்டாங்களா?
Sir, இன்னும் வரலங்க சார். சார் இன்னும் வரலங்க சார்.
அப்படியா?
ஆமா சார்.
அனுப்பிட்டேன் லிங்க். சோமு ட்ரை பண்ண சொல்லுங்க.
எஸ் சார் பண்றேன் சார்
சோமு சார்.
பண்றேன் சார்.
சோமு
சார் ஸ்டார்ட் பண்ண சொல்றாங்க சார். சார் வராங்களா சார்?
தேங்க்யூ. அண்ணயா
Yes, sir. Yes, sir.
அமோஸ்.
Yes, sir.
ஸ்டார்ட் பண்ணுங்க.
Let's begin this seminar with hopes, trust, faith, and deeds on Almighty. Warm welcome pleases the hearts, and that enlightens the minds. I'm happy to invite Dr. Ambet Raja, Associate Professor of the Department of Computer Application, to welcome our leaders and the gatherings for this webinar on HADOOP architecture. Yes, sir.
Yes, sir. Thank you, sir. A very good morning to all the delegates, research scholars present for the webinar on HADOOP architecture. On behalf of our Tirthangal Nadar College, I am extremely honored and glad to welcome everyone for this program. My hearty welcome today's guest, Mrs.A. Vijayalakshmi, Assistant Professor and Head in Charge, D.G.Vaishnav College, Chennai. I welcome our Honorable Secretary and Correspondent of Tirthangal Nadar College, Sri M.G. Chellapalam sir. I feel it's a privilege to welcome our most respected principal, Dr. S. Murugesan, and beloved vice principals and dynamic various heads of the departments of our college. I'm very sure that the program will be highly beneficial to those upgrade their technical skills. I'm indeed delighted to welcome our chief guest for having spent the golden time with us. Welcome you, ma'am. My welcome goes to all the staffs and research scholars who are going to make this event a grand success. Welcome you one and all. Thank you. Thank you.
Let us introduce our chief guest. I may call upon our beloved principal, Dr. S. Murugesan, to give us a brief introduction about our today's chief guest and special addressee of this seminar. Yes, sir.
Yes, very good morning, one and all present here. Most respected
Good morning, sir.
guest is most respected our Secretary and Correspondent, Mr. M.G. Chellapalam sir. Respected today's guest, chief guest, Mrs. Vijayalakshmi, Assistant Professor and Head in Charge, D.G.Vaishnav College, Chennai. Respected Soma Sundaram, Head of the Department of BCA Department, and other faculty members, and one and all present here. I deem it is a pleasure to introduce Mrs. Vijayalakshmi, Assistant Professor and Head in Charge, D.G.Vaishnav College, to this webinar. She has 17 years of teaching experience with excellent programming and analytical skills. A highly motivated and versatile and self-starter. She has produced 100% results and received Best Teacher Award. And she has published many research articles both at the national and international level. Her areas of specialization includes service-oriented architecture, cryptography, information retrieval, networking, web services, and so on. She is good organizer of conferences and seminars. And she has the credit of being the resource person in a number of webinars and seminars. She has also organized and participated in a number of FDP programs. I am sure that we will be able to seek a little guidance from your thoughts. I am very happy to hear such a personality in our midst. Thank you, one and all.
Thank you, sir. Thank you, sir.
Secretary வந்துட்டாங்களே? Shall we call secretary few words to join here?
சார் வரேன் இருக்காங்க சார், கொஞ்சம் லேட் ஆகும்.
Okay, okay. You proceed. You proceed. You call
okay.
the chief. You call chief guest.
Okay.
I request our honorable chief guest, Mrs.A. Vijayalakshmi, to take over this seminar time with her preparedness and the enlightened thoughts. Kindly take over, ma'am.
Yes, thank you, sir. Thank you all. Very hale and healthy good morning to all gathered here. First of all, my sincere gratitude to the management, Secretary Thiru M.G. Selabalam sir, Principal Dr. S. Murugesan sir, Head Department of Computer Applications, Mr. K. Somasundaram sir of Tirthangal Nadar College for having invited me as a resource person. Thank you all. And I welcome all the participants for this session. And before proceeding with, I would like to share a few informations based on my today's topic, Hadoop. In our daily life, we are entirely being dependent on the term, messages, informations, internet, and so many things. And also, we know that there's nothing without these informations or internet or sharing of messages in this current world. And starting from morning till dusk, we convey and do everything in the form of messages and informations only. So, mostly in all of our domains, fields, and our houses, we may be able to see such types of connections and informations and messages and so on. And also, being in this technical world, we are getting updated every day technologically. So we'll be surfing some of the advancement in this session, and especially how these informations and messages are going to be stored in various latest technologies like big data, and how these data will be analyzed with the help of some architecture known as Hadoop and all of these. So hence, without stealing much of your time, let me take on with my slides. Is it viewable, sir? Sir, shall I proceed? Is it viewable? Hello? Sir, my screen is viewable. So let's begin with our webinar on big data analytics and Hadoop. Actually, before proceeding with the architecture of Hadoop, we know some informations related to big data also, because all these informations related with big data, we are going to analyze in type of some manner related with Hadoop. That's why I've chosen some of the informations to be dealt with big data before going to the Hadoop architecture. So what is big data analytics? So in this current era, it's a very hottest buzzword around, and with the very small amount of data being generated every minute, every seconds by the consumers, and the business worldwide, we used to generate lot of informations and messages, especially in the form of very huge value of data to be found in big data analytics. Hence, these data has to be processed in some manner. these data has to be stored or analyzed or has to be kept in some order before it could be processed with some other technology. So there comes the word big data, and it has a few key characteristics as well, as such as volume, source, velocity, variety, and veracity. So based on these three five values, we are going to have our distinguishing of big data. So it's a newest resource as well for competitive advantage among nations, organizations, and business, where you could see data is emerging as the newest resource of this competitive world. So we'll be seeing all these informations about data in a detailed manner. So what is big data analytics? It means the term which is meant for unknown correlations, market trends, and some of the customer preferences. And these types of data analytics is a process which is used to extract some of the meaningful information about these patterns. For example, we have some cost reduction, the new products and services, faster, better decision making. So all these informations we are going to process in some manner so that these informations could be of with meaningful sites. And also it provides various advantages so that it could be used for better decision making, preventing some of the fraudulent activities which is happening in and around, and among other things as well. So because of these reasons, because of these main objectives, we are having big data analytics behind it. And why is more important, why we are particularly about why we are very particular about big data analytics. So I've taken this as an example of a company which has generated about 96 million users, which could generate a tremendous amount of data every day and every minute. So we have been fueling everything based on online activities in every industries. Hence, these information will be providing a platform so that it could be a cloud-based or platform automatically generates some songs, images, videos based on likes, shares, some search history, and more and more. So these informations will provide a streaming platform for all of the informations, which enables us to use the techniques, tools, and frameworks that which produces a result of big data analytics. So because of these some of the reasons, we have our big data analytics in our daily streaming. And how your informations have been passed out. So on receiving of the informations, usually the big data will come like this. So after having some analytics based on the informations applied on the big data, your decisions will be the thing like this one. Means that your unstructured informations will be structured like this. So this blue color represents a group of informations, and pink as well as the purple relates to some grouping of informations among themselves. And what's actually the term big data defines? It is an amount of data sets, usually a massive amount of data sets that cannot be stored, processed, or analyzed, because we have been using some of the traditional tools in our olden days, like database architecture or database management system, where we could store our data, informations, messages in some other tools or in some other form. So those tools, traditional tools, would which will be of vain process, because we are generating data each minute, each second, and every second it's tends to be generating massive amount of data. So since these traditional tools have gone in vain, we have gone for such big data has to be analyzed and stored in some form of advanced technology, that is larger sources of data or social media platforms and networks. So we are using Facebook, which is a very major example in our nowadays situation, which could generate more than 500 terabytes of data every day. So these data may be of pictures, videos, images, and so on. So how I'm going to generate these terabytes of data, these massive amount of data, into one traditional, I mean, into one very technological oriented and an advanced technological tools. So that's why we go behind big data. This defines the actual definition of big data. And as I have explained you in the previous diagram, that what are the informations messages were received from various platforms, it will be structured, semi-structured, as well as unstructured data. So in contrast, I mean, if you have a regular Excel sheet, means you may have some order of data, or you may have the data and information in a structured format. In a Word means it's a document format. In a PowerPoint means you'll be having the data in a slide format. Whereas in email, where you may see semi-structured and your pictures and videos, which completely falls under unstructured data. And all these type of data have to be combined to make a big data work together. Hence, its raw form is of no use. So what are the four advantages we may extract from the analytics of big data? So let us see, because we are having structured, semi-structured, and unstructured data, and based on these categories, how you are going to have an analytics of these type of data with some of the advantages as well. So benefits and advantages of big data analytics I have given. So first comes the risk management. Second one will be the product development and innovations. And third one will be the quicker and better decision making. And fourth one will be the improved customer experience. Because I have given the all the advantages with some use cases, so that you may have a deep discussion about the advantages of big data analytics. So first comes the risk management, where I have given an example of Philippine banking company, which uses big data analytics to identify some of the fraudulent activities and discrepancies going in and around the company. So what are the problems of flaws, and what are the errors they may undergo each day based on banking. So all these activities could be based, I mean, could be traced using the risk management of big data analytics. And also the organization, it's narrowed down a list of suspects or root causes also. It had its own definition for having these types of suspects or root causes of some of the problems as well. And coming to product development and innovations, and Rolls Royce, where we are all aware of this company, one of the largest manufacturers of jet engines for airlines and arm, they have used. They have been use of big data analytics for some kinds of development and innovations on their own manufacturing of jet engines. And coming to quicker and better decision making, what could be the example I can give us? It is, I mean, Starbucks, it's a company which is used to find a particular location. It's maybe on based on GPS and something related to that. So, which particular location would be suitable for a new outlet or not? So, based on this analytics, they are going to have some decisions. So, for that, they use big data analytics as a tool for making quicker and better decision making within their organizations. So, they will analyze some different factors such as population, demographics, accessibility of the location, and so on. So, this is an example given for the advantage of big data analytics. and how you are going to improve your customer experience. So a famous airlines, Delta Airlines, they use big data analytics. These are all one of the samples I have given, but you may find many of the concerns and companies, they use big data analytics as their tool to improve their customer experience. And so they monitor tweets to find out the customer's experience, what's their feeling when they want to travel, and what's their suitable positions on journeys, and what could be the delays and flights, and when what's the arrival time of the flights. So everything will be denoted with the help of these big data analytic tools to provide a remedy to the particular situation. Hence, by publicly addressing these issues and offering solutions, it may, I mean, the airline may help to build good customer relations also. So these are the four major advantages of big data analytics. And coming to the life cycle and the phases of big data analytics, we have around stage 8, I mean, sorry, stage 8 of life cycle. So first stage will be the business case evaluation, in which you're going to have the business with each business case, which defines the reason and goal behind the analysis. Means that you're going to have a you're going to analyze the data behind it with each of the business case. So that falls under the stage 1. And in stage 2, you're going to have the identification of data, wherein you may have a very broad variety of data sources that has to be identified. And stage 3 is the data filtering, where you may have all the previous stages. I mean, if you're going to extract all the informations from the previous stages, and at one point of stage, it has to be filtered out. The data has to be filtered out, in which you're supposed to remove only the corrupted data. And stage 4 will be the data extraction, which is not compatible with the tool. I mean, if you have the particular tool or platform, and if some data they are not compatible with the tool what you are using, means then it has to be transferred to the compatible form. So in this stage, you may have the data extraction to be followed. And stage 5, we may have some fields across different data sets or integrated. So aggregation, in the sense that what are the data needed for its activity to be completed. So those data sets have to be integrated together for the stage of data aggregation. And stage 6 is the data analysis, in which the data is evaluated using analytical and statistical tools to discover useful information. So, based on the analysis of the data, you are going to segregate what are the useful informations and what are the extracted useful data from the already existing data with some kinds of statistical tools used with it. And stage 7 is the visualization of data, where you may have this tablet, power bank, then Qlik view is a very important tool of visualization of data, and as well as Tableau. And these data, they may have a very graphic visualization of the analysis by means of bar diagram, pie diagram, chart diagram. So with the analytics of these tools, we are going to have the visualization of data in our stage 7. And stage 8 will be the final analysis result, which could lead you to the last step of the big data analytic life cycle, where the final results of the analysis are made available to business stakeholders who will take action. So they are the end users, or they are the stakeholders, which they may have the final results of the data has to be analyzed, which will be made available to those persons, those business stakeholders, or consumers or customers, who will take corresponding action against them. So these are these 8 stages we have seen through. And what are the different types of big data analytics? What are the types? I mean, we are going to analyze these type of data, and behind that analytics, what are the types we have? So descriptive analytics will be the first one, which summarizes past data into a form that can be easily readable, or it can be easily transformed to the customers. So for example, like creating reports or companies profit, sales, loss, revenue. We are going to predict, or we are going to describe some of the data which has been analyzed. Based on that, you are going to have a file or have a segregation based on those type of descriptive analytics. So use case I have given the Dow Chemical Company, which has analyzed what are the problems and what are the past data to increase facility utilization across its office, and what were why it has been lagging, and what are the ways to improve its company to lag facility utilization, and to identify some underutilized space also. So this is the use case I have given for descriptive analytics. And diagnostic analytics which cause a problem in the first place itself. So if the problem has been divided into many stages, in the first stage itself, I'm going to identify what's the root cause of that particular problem. So techniques like drill down, data recovery, data mining, or some of the examples of this diagnostic analysis. So the organizations, they may use these type of analytics to provide a very in-depth and very insight to a particular problem. So an example I've given as an e-commerce company, they have created their sales which have gone down for a particular period. On analyzing, they found that almost all the customers are adding the product to the carts, but even though the e-commerce company have some gone down in their sales. So based on analytics, they found that due to various reasons, like the form that have not loaded correctly, the shipping fee is too high. So these are some of the reasons for their company to go down, and there are not enough payment. I mean, there are not enough payment options. So only it could be restricted for credit card customers or debit card customers. Likewise, the payment options has been restricted to some forms of some types of customers. So these reasons may have gone the companies, e-commerce companies, to go down, where you may use diagnostic analytics to find a particular reason. And predictive analytics, this will be usually used in the field of medicine, because you are going to predict with the forms of symptoms, the types of symptoms what you have. You are going to predict what will be the future I mean future predictions of that particular data. So looks into the historical and present data to make predictions, and what are the things you are going to have from the current data. And from the current data, I mean, this you may have as an example for real estate also. At this current year, this square feet of land cost this much, means within 2 years or 3 years, what will be the square feet may go on. Likewise, you may have the prediction of the particular data. So I've given the example for PayPal, which determines the kind of precautions they have to take to protect their clients against some of the fraudulent actions and some of the flaws. And also, based on the historical payment of data and user behavioral data, they have to build an algorithm that predicts fraudulent activities. So what are the things which makes the company have gone down, and from the current data, what could be the predictions could be done for the data to be improved in some manner, to be improvised, and the data to be improvised to a very high level. So what or the analytics could be done, may be done using predictive analytics. and prescriptive is the one which prescribes the apt solution to a particular problem. And so this works with both descriptive as well as predictive analytics also. And you may tell that it's a combination of prescriptive as well as descriptive, and in most of the time it relies on artificial intelligence and machine learning. So I've used prescriptive analysis which could be used to maximize an airline's profit, in which this type of analytics it is used to automatically adjust the flight fares. Say for example, if we are in vacation, means definitely the fare of the flight will go to a very high currency. And also if it is raining, based on the weather conditions, the the fare of the flight will be will reach its crest or trough, and including some customer demand, weather and holiday seasons and oil prices. Based on oil prices and based on the destination, we may have the various inflations with the flight prices. So this describes the prescriptive analytics. And coming to big data analytic tools, where you have some key big data analytic tools as Hadoop, MongoDB, Talent, Cassandra's packet, wherein each of these tools stands for especially certain specific characteristics of. For example, Hadoop means it helps in storing and analyzing data. So that's the peculiar feature of Hadoop. MongoDB DB means it is used on data sets which changes frequently, which have inflations in the output. And Tilen will be used for data integration and management. Cassandra, it's about a database which is used to handle very chunks of data, very numerous amount of data. And Spark is a thing which is used for real-time processing and analyzing very large amounts of data. And Storm and Kafka, which is Storm is an open source real-time computational system, and those type of applications will be dedicated to this tool Storm. And Kafka is a distributed streaming platform which is used for fault tolerant storage. So these are some of the tools which we could see on the architecture of big data. Then coming to applications, we know that big data has been its own applications in many fields such as healthcare, media, banking. So coming to healthcare means it is used to have the prediction of patient's medical history, which is used to predict or show some likely what are the health issues may be related with the past history and so on. And media and entertainment, where we could have the demand of movies, songs, shows, and it's more to deliver a personalized recommendation list to its users as well. And coming to banking, it's based on some spending patterns, help to predict what we have our password and the likelihood of choosing various banking offers like loans, credit cards. So loans, credit cards, and all these informations will particularly and entirely based on the database of the customer, or what are the how many customers does the bank have likewise. So these are some of the applications related with banking. And coming to marketing, which acts as one of the major application of big data, and it helps to drive high round of informations marketing campaigns which result in improved sales. So these type of analytics, which is as we have seen in the earlier slide itself, based on predictive as well as descriptive analytics, your marketing, you may improve your company's marketing to go to a very high manner. And education, which is used to develop new and improve existing courses based on market requirements at present, because we had some of the old languages and applications in our past years, but recently we have many developed applications and languages based on our education. So this education field is also very it found its application to be highly oriented with big data analytics. And government, it helps governments in law enforcement and among other things as well. And telecommunications, which is used to forecast network capacity, and also which is used to improve the experience of the customer. So these are some of the applications which may you have for big data analytics. And coming to Hadoop, which is a very important architecture which we may find as a tool in big data analytics. First of all, the definition of Hadoop and what's a Hadoop mean. It's an open source framework in which you have the return language in Java that allows distributed processing of large data sets across clusters of computers using very simple programming modules. So that's the essential feature of an Hadoop, that it's an open source framework which is written in Java. And also it provides distributed storage and computation across clusters of computers. And especially it is designed to scale up from single server to thousands of machines, wherein you may have the thousands of machines connected to a particular server, each offering local computation and the parallel computation as well as the storage. So you may have a dedicated server in the middle, and from that particular server you may have the n number of machines connected to the server, each as being processed and computing its own specifications or operations, and they may have the own storage as well. And as we have seen that there are 5 weeks of big data which we have given in the first live volume, veracity, velocity, and all those types of V's which we have seen in the previous slide. And this is the exact architecture of Hadoop, which you may have two major layers. The first one will be the processing or computational layer, which is known as MapReduce, and the storage layer, this Hadoop distributed file system, which is acronym as HDFS. So these are the two major layers. In association with Yarn and common utilities, you may have the architecture of Hadoop, whereas Yarn and what are the common utilities you may be seeing in the forthcoming slides. And coming to Hadoop, there is a Hadoop distributed file system HDFS, which is a dedicated file which is used to store very large amount of data, enormous amount of data with streaming access pattern. That's the main point to be noted with HDFS. It's a streaming access pattern which enables us to be stored at multiple nodes in the cluster. So if we want to access a particular information in one particular region, means if the information has been lost or due to some errors, means it could be retrieved from any other node which it has been stored, so that any fault tolerance or data security or any missing of data could be avoided. So that's the main feature of HDFS. And MapReduce is a thing that it also needs some, it's the data which is stored in the HDFS, and also it needs some mapping to be related. If you have the grouping of data, if you have the mixer of all data assembled together in a single place, means for the grouping of data, for the mapping of data, and at last the output of data to be extracted in one place, we need this MapReduce architecture, which identifies where the particular data is stored, and where it has been broken into multiple parts, and what are the results of these multiple parts on combining, so as to produce the exact overall result. So all these will come under map. So once you're going to have all these data together in a specified place, means that that refers the map. And once if you're going to extract all the results, means that defines the process reduce. And yarn is a very important tool with Hadoop. It stands for yet another resource negotiator, which functions as a framework for job scheduling. So, as we have seen in operating system, that which job has to be proceeded next based on some priority, or and based on some task has to be achieved. Likewise, we may have some scheduling algorithms with operating system. So this is also one type of job scheduling in Hadoop, which has various types of scheduling, such as first come first serve, fascia scheduler, and capacity scheduler, etc. So usually it is based on first come first serve scheduling, which is a default set in yarn. And map reduce, it's been related with distributed processing. So these are the components related with your works I've shown. And HDFS is the thing which is related with the distributed storage. So all the storage of data which has to be distributed among their nodes will be done by HDFS. And yarn is the thing that yet another resource negotiator, which is done for job scheduling, and it acts as the resource manager as well. And Hadoop Common, which is used for common library functions and some of the scripts related with Java. So this is the basic diagram about MapReduce as well as HDFS, wherein I have denoted what are the things related, I mean, what are the operations related with your tools I have given as an architecture. And coming to MapReduce, the major function of MapReduce is to perform the distributed processing. So the job has to be distributed because, as we know, that our resources are very costly. So the resources has to be utilized in an efficient manner. For that, the parallel processing is a very important concept, which makes the cluster to work so fast. So when you're dealing with such type of big data, serial processing is no more of any use, and parallel processing is a very important task behind it, so that the resource utilization will be of very effective and will be of very high manner. So map producers has mainly two tasks which are divided phase wise, as I have said you. One will be the map task and one will be the reduce task. So at first we are going to have all our input as a big data, and each of the data will be distributed to each of the components of map, like grouping of data, wherein you are going to have these aggregations like videos, images, and the combinations of text messages and all these things. And based on the grouping, it will be allocated to the reduce process, which is going to have the stream of data with your grouping, and at last it will be provided as an output to the map function. I mean, from the map and reduce function, we are going to extract the exact output along with the grouping of data. So this is the action, or this is the uh, operation what we are having behind map and reduce function. And map your we have already known that the input has been given as a grouping of images or grouping of files to the map function. From the map function, with the help of key value pair, I mean, the data blocks will be divided into tuples is nothing but record each record in a row manner refers to a tuples, and this reduce functions will combine all these broken tuples or key value pair based on its formation of tuples. I mean, if I want to fetch a particular record, say for example, fifth record means I'm going to have the tuple of fifth record, wherein the particular tuple will provide all the informations of fifth record: his age, his roll number, his qualification, his designation, and all those things will be formed as a tuple. And some operations will be performed with these tuples like sorting, summation, which we may have the output based on those operations. So like this, the final output will be obtained for map reduce function. And map task, as we have already known that it is responsible for providing key value pairs in a map function, which is usually related with the locational information of value. Why I'm being particular about the locational information is that it it provides all the details of the data node, where it stores, where the data gets stored, and what is the address behind it, what are the operations has to be performed, and how it will be proceeded to the next information. Likewise, all these informations will be given by this map function. And once process has to be done with the tuples means it will be obtained from the record reader. Record reader is the thing that you're going to record all the operations of a particular tuple. So once you're going to have some extraction information on the particular tuple means you may generate any key value pair or generate multiple pairs of these tuples. So how these tuples has been related with other informations or data, how it has been mapped with other informations or other locations, where it has been actually extracted, and what where it has to be related with, like all these informations will be generated in map function. And the combiner, it is also used for grouping the data for the map workflow, which is nothing but we are going to combine the extracted output with the related information. Say for example, if I have the fifth, sixth, seventh of letter tuples to be kept in a particular location means those tuples alone it will be combined to a particular location. Like this, we are going to have this combiner for all the grouping of data in the map workflow. And partitioner, so likewise combiner, we have the partitioner also, which generates the shards corresponding to each reducer. So as we have seen, it is going to combine all the related informations or related images together in a single place. How it could be reduced? So after segregation, what are its responsibilities, what are the responsibilities of a particular image, where it has to be partition, where it has to be allocated, where it has to be fetched, and what are the things has to be extracted from this partition. Likewise, all these operations will be performed for fetching key value pairs generated in mapper phases. So all these all these operations will be related with partition, which is a very important modulus which reduces the number of reducers. Example, key hash code that reduces the number of reducers. For if data has been replicated in many ways in many places means this reducer key function, it is used to reduce the number of replica pairs in each of the nodes, because as the data is very much important to be stored in many places due to retrieval or due to crashing of that particular data, but it's important that it's been stored in some other place without any use means that has to be deleted or that has to be reduced. Hence this partitioner and reduce cause, which is used to segregate as well as the responsible for reduction of process, and especially in shuffle and sort, which have the task of reducer starts with a step, so that the mapper, they may generate the intermediate key value and transfer them to the reducer task. So it is going to have the shuffle and sort mechanism, so that each of the reducer, they may have their own relation of key pairs to be mapped. So that's what the partitioner as well as the reduce task done. And what could be the output format of all these operations. So once the key value pairs are written onto the file with the help of a record writer, each record in a new line and the key and the value in a space separated manner. So after having partition or after having a reduce function, you may have the all tuples of records in a group manner, and it has been associated with the operations or performed to the destinated file. So shuffling or sorting operation has been done with these all grouping of images which has been related from one place to another. So they may share the works space among each of the nodes, and from the nodes you may segregate these data to be separated together, so that you may have the output of all the operations perform as a key value pass. And how you're going to have this HDFS splitters. So you may have various nodes, dedicated nodes. Actually, this architecture will be based on master slave architecture, where you may have various map nodes to be processed together for parallel processing, and each of the input key value pairs will be given to those map functions, and after the shuffle and sorting operations has been performed with these data. Here k and v, there is a k1 relates to the key 1, and kk relates to the term key k, and vk relates to the term value k. So with this combination of data which has been split together into their corresponding map nodes, and by the combination and the segregation of K1 and V1, KK, VK in each of the map nodes, it has to be sent to the aggregate values. That is to be shuffle and sort by some means of mechanism, wherein you may have the reduce of their output with the grouping of images, which you may have the extraction of images like final key and final value. So this is the basic architecture of how the master as well as the slave node operates or explains. So you may have the combination of all the outputs from various images. Thus, by shuffling and sorting of the aggregate values by key pairs, you may have the reduce function with the final key as well as the final value. And it's a distributed file system which is runs on commodity hardware. So it's highly fault tolerant, and it is design which is used for low cost hardware. So you know, need not go for a very expensive hardware and all these things. It is a very simple architecture which may have its applications to run on a very low cost hardware itself, and it is used to store huge data, as I've mentioned you earlier, and the files are stored across multiple machines, so that retrieval of that particular files or due it may be deleted, or it may be crashed due to some failures. So those type of files will be retrieved because it has been stored in multiple machines, and it's stored in redundant fashion to rescue the system from possible data losses. So if data has been lost due to some failure, means it also makes applications to retrieve since it's in parallel processing. And what are the features? Means it's for distributed storage and processing, and it provides a common interface to interact with the Hadoop. And there are many built-in servers of name node and data node. So master slave node, uh, which helps user to easily check the status of the cluster where it has been combined together, where it has been extracted, where it has been mapped. Likewise, it may help the built-in servers to easily check the status, and streaming access to files system data, and also it provides file permissions as well as authentication. So this is the architecture based on slave and data node, I mean master and slave node. So this is the name node, wherein the client will be accepting all the read operations, and once the read operations has been accepted from the client, its metadata will be sent to the name node, wherein the name node, it is used to separate all the data such as replicas of data and where it has been originated, what's the exact path of the data. Likewise, the name node will be having a detailed information of the particular metadata, and these are the data nodes. I mean, this is the data node 1, this is the data node 2. So this is the replication of the file which I have mentioned. So if there is any failure with that particular file, means this replication of data will help us to retrieve that particular file from the particular location, and the data and the files are saved in each of the data nodes, and the name node will be acting as the master node by giving so many commands and instructions to each of the data nodes, so that the files will be extract from the particular data node such as rack 1 and rack 2. So this is the basic architecture of Hadoop. And the name node, it's a software that can be run on commodity hardware, as I've mentioned you earlier, and it's a system having the name node access the master server. So name node is an important node which access the master server, and it is especially it's responsible for the following tasks, such as it manages the file system namespace, how many space, I mean, what's the volume of the space to be allocated to the particular file, and it regulates clients access to files, and also it is responsible for file system operations such as opening of files, closing of files, renaming, and what are the files and directories behind it. Likewise, all these operations are basically related with name node which access the master node. And data node, which also mentioned as slave node, on receiving the commands and instructions from the master node, it acts for every node. There will be an commodity hardware and system, there will be a data node, and these node will manage all the data storage of the system. They have their own classification of files, they have their own architecture and hierarchy of files. So all these files will be maintained by these data nodes, such as block creation, deletion, replication of data, how many blocks has to be allocated, which program or which file has to be seated in which location, and how many data has to be inserted, what are the data has to be deleted. So likewise, all these instructions and all these management, all these supervision will be done by the data node of their particular files allocated to it. And block is the thing that you may have segments, or you may have your file system divided into many number of blocks, and these segments are called blocks, which will be saved in your data node, and this is the minimum amount of data that helps the HDFS to read or write. So the default size of a block is 64 MB, but now in recent days they have increased the 64 MB to 128 MB, where you may have the block of data in a huge amount of size, and this block of data may be seated in the data nodes to change the configuration of HDFS. And what are the goals of HDFS? Huge data sets could be occupied, could be accommodated, then fall detection and recovery could be avoided, and large number of commodity hardware, failure of components is frequent. That's why we go for fall detection and recovery, which helps us the mechanism for quick and automatic fall detection and recovery of data. Then huge data sets means hundreds and hundreds of nodes per cluster. You may have the applications to be managed with such huge data sets, and hardware and data means it could be done efficiently when the computation takes place near the data itself. So huge data sets are involved, thus by reducing the network traffic, and you may increases the throughput is a thing that we all know, that the amount of time taken by the node to access the particular file. So these are some of the goals of HDFS. And what's the particular thing about YARN is to remove the bottleneck on job tracker, which was present in Hadoop 1. So it has been described as redesigned resource manager, because it has now evolved to be known as large scale distributed operating system used for big data processing. Because without yarn, you cannot have the process of architecture of HDFS. With that, to that extent, this yarn supports the job of Hadoop architecture. And coming to architecture of yarn means, as I have mentioned, that it is the job scheduling operating system which collects all the operations to be performed with the help of job tracker, and each of the job will be uh, segregated or group or sent back to the specified operations known as task tracker. So it is, its job is to collect all the informations from the processing layer, and based on the processing or operations, its job tracker, it's split into it's split between the resource manager and the application manager. And also it allows different data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process stored data in HDFS. See, I have given MapReduce and other data processing frameworks which has been associated with yarn as well as distributed file system. So yarn access the job operating scheduler, which gets in all the job operations from the clients. By the help of MapReduce and other data processing frameworks, the files will be distributed among these two levels of architecture. So, what are the features of YANA? Scalability, compatibility. As we know that the resource managed of YANA architecture, it allows Hadoop to extend, and it will be managing thousands and thousands of nodes and clusters. So that defines the scalability of YAN features. And compatibility, it supports the existing map reducing applications without disruptions, without having any disturbances. Thus, it makes a very compatible environment with Hadoop as well. So, these are some of the features of Yarn, and this is the example I've given for utilization of cluster, multi-tenancy, and all these things. So, wherein you are going to retrieve all the informations from the client, which makes us the process one, and all the process will be sent into the resource manager, and then the resource manager will get in touch with the application manager to retrieve or to acquire some of the needed resources for this process has to be done. And the application manager when in turn asks for the number of resources, and based on this number of resources sent to the application manager, it dedicates all the resources to the resource manager. And the application manager also, it indicates an task has to be done to the node manager. So the client, which operation has to be done proceeding to the next operation, means that will be retrieved from the client process. So by having the combination of the task to be done from the application manager and client manager, the node manager, which acts as the slave node, will be performing its particular operations. And once all these operations has been done, the resource manager will be getting some more applications from the client, which is used for further operations or further maintenance of all these activities could be in process for the following things. So likewise, these client resource manager, node manager, application manager may have the contacts of all this information stored within themselves in a sequential order, so that they may have the processing of each of the steps in a defined one. So therein, the workflow of application, especially with Yarn Hadoop, makes it. So I have given the definition of this thing. So client submits an application and the resource manager, it allocates a container to start with the application manager, and the application manager registers. So it will be looking for all the resources or that has to be allocated to the resource manager, and based on some negotiation. Suppose if the application manager has only three resources with it, means, I mean, three containers with it, means it negotiates those three containers to the resource manager, and it notifies the node manager to launch more containers, because if the resource manager, it has asked for some five resources to be allocated, but the application manager has only three or four within it, means it may ask some request from the node manager to launch some more containers to the application manager, and the application code is executed in the container itself. And the client, they may have a contact between the resource manager and the application manager to monitor all the status of applications. So once the entire processing has been completed, means the application manager, it unregisters with the resource manager. Unregisters, why it unregisters? Because it should give a way for other resources or other actions or other performance to be allocated, like so it has to delete all the previous informations or process to be deleted. So this is the exact system of that architecture which I have described. And what are the ecosystem of Hadoop? That is, it provides various services to solve the big data problems, and it includes Apache projects and various commercial tools. So there are four major elements of Hadoop, that is HDFS, MapReduce, Yarn, and Hadoop. So some ecosystem also I have given us this one. So these are the common ecosystems that collectively form a Hadoop. And so HDFS, which stands for Hadoop Distributed File, where you want your system, file system, to in a distributed manner, means you may go for HDFS. And resource negotiator will be Yarn. MapReduce, which is completely based on programming based data processing. Spark as an ecosystem which is used in memory data processing. And Pig and Hive, these are two tools especially used for mm, coding or query based processing of data services. And HBase, it is used for NoSQL database. And Mahout, Spark, MLlib, these are some of the libraries especially oriented with machine learning algorithms. And this is the basic structure of Hadoop ecosystem, where we may have these components like Uzi, Chukwa, Flume, Zookeeper. All these comes under the ecosystem data management, and the data access will be responsible for Hive, Pig, Mahout, Avro, Scoop. So all these tools or some of the architecture of ecosystem which falls under data access. And data processing means, as we have seen, that MapReduce and Yarn, these are the two client manager management system which oriented with especially for data processing. And data storage is a basic one, where we have HDFS and HBase as a common thing. So this is the overall ecosystem of Hadoop. And I think I'm done with all the things. So if you have any doubt, may please.
Ma'am, thank you very
Yes,
much,
sir.
ma'am. Nice
Yes, sir.
presentation.
Thank you, sir.
Any questions
Yes,
from
thank you.
participant side? Any questions? Any questions? Any questions? Any suggestions? Any feedbacks? Everything is welcome. Okay, Amo sir.
To record our gratitude for fulfill of our needs and deeds for the success of this seminar. I invite our assistant professor S. Sandhya Sabu of the Department of Computer Application to render the vote of thanks.
வாயை வச்சு பண்ணேன்னா அது தப்பிடலாம் அதெல்லாம் போன கூட வாயை வச்சு உரிக்கணும்
Sandhya ma'am, Sandhya ma'am, Sandhya ma'am connect ஆகல.
Sir, you can give. No problem. What of that?
Sandhya ma'am.
One time. Yes, ma'am.
Sandhya ma'am.
Praveen sir. Yes ma'am. Am I audible sir?
Yes ma'am, yes ma'am.
Sir, am I
Please.
audible?
Please provide your vote of thanks. Please provide your vote of thanks.
Yes sir, sure. Good afternoon to everyone. The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. Today my words are not enough to express my gratitude. On behalf of the Tamil Nadu College, I would like to thank our chief guest, Mrs.A. Vijayalakshmi ma'am, who graced us with her knowledge and set a perfect platform. We all are inspired by the way you have your presentation, ma'am. Thank you. I would like to thank our energetic secretary and correspondent, Thiru N.G.E. Selapalam sir, our beloved principal, Dr. S. Murugesan sir, and vibrant vice principals, Dr. K.C. Lalitambiga ma'am, and Professor S. Asethambi sir, for all words of wisdom that radiated a source of energy within us. We will ever remain grateful, and we all thank you all for being for being with us today. Heartfelt thanks goes out to the management, the head of the department, Mr. K. Somasundaram sir, and all our faculties who led us and motivated us to conduct such an event. I thank everyone for the involvement they have shown and their willingness they have expressed to take on the completion of such a grand successful event beyond their comfort zones. Last but not least, I would like to thank all our participants who have showed their interest in this program. Once again, I thank you all who made this webinar a grand successful. Thank you, ma'am. Thank you all.
Yes, thank you.
Yes, thank you.